Welcome to Second Take, the show that focuses on the issues behind the news. 50 years ago, Yuri Gagarin became the first man in space when he made a single orbit of the Earth. Engineering News Senior Deputy Editor Keith Campbell joins me in studio as we reflect on this historic space mission. Keith, welcome to Second Take. Can you reflect on the engineering feat that was achieved by the then USSR on April 12, 1961?
Well, it was an extremely impressive feat to be able to put the first man, the first human being in orbit. It was a result of a lot of extremely hard work on the part of the engineers who designed and executed the program. There's a saying, it's not rocket science. In fact, rocket science is dead easy. It's rocket engineering that's incredibly difficult. Now, the Russian-Soviet tradition of rocket research went back several decades. The great theoretician of rocket engineering, Konstantin Tsiolkovsky, was a Russian working in the late 19th, early 20th centuries. And Russia had a rocket design bureau before the Second World War, but its personnel were caught up in Stalin's dreadful purges. A number were shot, most of the rest were sent to labor camps, and all work stopped, only to be reactivated, and the engineers were called from the labor camps after the Nazi invasion of the Soviet Union in 1941. They went from producing small liquid-fueled rockets in the early 40s to producing what was then the biggest rocket in the world in the 1950s, a rocket they called the R7. That designation was secret and not revealed to the wider world for decades. And I think in the West we called it the SS6 because we had no idea what the real name was. The R7 was such a success as a space rocket. It was meant to be an intercontinental ballistic missile, but was a total failure in that role. But as a space rocket, it was such a success that the R7 family, are still in production today, are still in use today. The latest version of that rocket family is known as the Soyuz. And it is the workhorse rocket for not only the Russian space program, but you could say for humanity's space programs. Today, European Space Agency and the US Space Agency make use of Soyuz rockets to launch payloads to carry people into space, launching from Russia, of course, although the Europeans have now constructed a Soyuz-specific launch pad in French Guiana, so the Russian rocket will be able to lift off from there. But this is basically just the latest refined version of that rocket that was designed in the 1950s.
The chief designer played an important role. Can you outline his contribution to the space mission? The
chief designer was Sergei Korolev. He is not a very familiar name because when he lived and worked, he sadly died in 1966 at the age of only 59, and his death severely disrupted the Russian manned space program and is one of the reasons why the Soviet Union never sent the manned mission to the moon. As I say, Korolev's identity was never revealed when he worked because the then Soviet leader Nikita Khrushchev declared his identity a state secret. He was only ever referred to in public as the chief designer. His role was critical. He was the driving force behind the space program. The R7 rocket, for example, as I said, was a failure as a ballistic missile, and some of Korolev's co-workers actually believe he wanted it to be a failure as a ballistic missile, that he designed it to be a space rocket, not a military rocket. It was Korolev who was the driving force behind the authorization of a manned space program for the Soviet Union. He roped in friends in high places and got them to persuade the Soviet authorities to authorize it. But he had designed program for manned spacecraft underway before he received official authorization. He was absolutely critical. He was the driving force behind it. He was not the only engineer involved by any means. There were the engineers who designed the spacecraft itself, the Vostok spacecraft, people like Mikhail Tikhonravov, Konstantin Feoktistov. There was Boris Chertok, who designed all the guidance and control systems. There was Valentin Glushko, who headed the design bureau responsible for the rocket motors, the RD-107, which is also the standard rocket motor for space exploration because it is still in production like the R-7 rocket in a refined and developed form today.
What happened 50 years ago changed the world. What lessons can we draw from it today?
I think that one clear lesson is that Korolev and his team had clear objectives. They knew what they wanted, and they were able to get the support of the country's government and institutions. Another important fact that I have mentioned so far was that the space program, the manned space program, led to a revolution in quality control in key sectors of Soviet industry. Because every part, no matter how small, every part for a Vostok spacecraft had to be specially labeled. It had to meet certain high quality standards. And the interesting thing was that the heads of the institutions and the factories responsible for these components had to take personal responsibility for each and every part that came out. They could not delegate it. They were personally responsible that this part was to sufficiently high standard to meet the needs of the Vostok spacecraft. So it's also clearly the importance of ensuring quality control in everything you do if you want to achieve things that are unprecedented.
Keith, thank you very much. That is the Second Take show for this week. Thank you for watching and join us again next time for more news analysis.
Led by Martin Creamer, Mining Weekly's bureaus in Perth, Johannesburg and Toronto deliver unrivaled global coverage of the resources industry and the companies shaping it. Creamer Media's Mining Weekly for mining news around the clock.